All right. Hello, everybody. Today we're going to continue with our topic Newton's second law of motion, concept of a system. Today we're going to work with the exercise or problem 10, which says a powerful motorcycle can produce an acceleration of 3.50 meters per square seconds while traveling at 90 kilometers per hour. At that speed, the forces resisting motion, including friction and air resistance, total 400 Newton. Air resistance is analogous to air friction. It always opposes the motion of an object. What is the magnitude of the force the motorcycle exerts backward on the ground to produce its acceleration if the mass of the motorcycle with rider is 245 kilograms? Okay, there are very interesting things here, and as you can see, we have an acceleration, we have a force, and we have a mass. All the things are needed in Newton's second law of motion problems as it states in a formula. Here in this exercise we have some forces, in fact one force, we have a mass, and we have an acceleration. But as you can see in the formula, there is no velocity, and in this case we have a velocity. So why do we have it there? La cuestión aquí es lo siguiente. Según la segunda ley de Newton, la fórmula de la segunda ley de Newton, tenemos fuerza, masa y aceleración, todas las cuales aparecen en este ejercicio. Pero en ningún lado aparece velocidad. En este ejercicio tenemos una velocidad. Why is it that? Why do we have a velocity here? Okay, let's consider this. Let's suppose that the motorcycle is completely stopped. At that moment, there is no air friction against the movement of the motorcycle since the motorcycle is completely stopped. Once the motorcycle accelerates and achieves a certain speed, there is going to be an air friction resisting the motion of the motorcycle, and the fastest the motorcycle goes, the strongest will be the force of the air resistance. ¿Qué es lo que sucede? Si la moto está parada, no va a haber una resistencia al aire que se oponga al movimiento. A medida que la moto se vaya moviendo cada vez más y más, va a haber más resistencia al aire, ya que mientras más rápido se mueva, mientras más rápido se mueva la moto, más resistencia al aire va a ir. En particular, en este caso, cuando va a esta aceleración, el motociclista y cuando va a esta aceleración y a esta velocidad, y solo esta velocidad, la resistencia al aire tiene este valor. No vamos a considerar la velocidad en este ejercicio, ¿ok? Solo es un dato adicional de que la resistencia al aire tiene 400 newtons cuando la velocidad es esta. Now, let's go to our blackboard and let's try to identify all of the forces that are involved here. But the first thing that I like to see is where does the acceleration go. And in this case, the acceleration is upward. No, sorry. It's going to the front. This is the acceleration. We also have two forces here involved. We have the air resistance, which opposes the motion. This is going to be the force of the air resistance. Besides, we have another force involved here, which is the force that the motorcycle exerts backward on the ground. These two forces are against the acceleration, and because of that, we're going to consider them as negative. Okay, so don't forget that. Both forces are going to be considered as negative since they are opposite to the acceleration. Okay, here we have all the forces involved in this exercise, and let's take our formula. This time, don't forget we have to use the Newton's second law of motion. There we have it. and for that we need to add all the forces involved. We have the force of the air resistance, which is negative since it's opposing the movement, plus the negative of the force of the motorcycle, the force that the motorcycle exerts backward on the ground. Sorry about that awful O. And that is going to be equal to the mass times the acceleration. Okay, here we have some values and some other values we don't have. For instance, we have the force of the air resistance, which is equal to 400 newtons. We have the value of the mass, which is equal to 245 kilograms, and we have the value of the acceleration. So let's start putting all of those values here. All right, so there we have them. And remember that what we have to do is try to isolate the force of the motorcycle. That's what we have to do. So for that, I'm gonna do next. I'm gonna write here minus 400 newtons. And since our known is negative, I'm going to send it to the other side as positive, okay? Don't forget that we also have to multiply these two numbers. So the answer for that is 857.5 newtons. Don't forget that we had to multiply the numbers and also the letters, and kilograms times kilograms times meters per square seconds is equal to newtons. And don't forget, I send the unknown to the other side, so it will be positive. Now, what I have to do is send the 857.5 newtons to the other side as negative. Finally, the answer for that is going to be 1,257. Oops, sorry about that. 57.5 newtons. And that's it. That's the end of this exercise. Don't forget that one of the most important things of this is the beginning. And let's try to assume that every force that is acting against the movement, it has to be considered as negative. In this case, we haven't got any force in the same direction of the acceleration, so there were no forces, there were no positive forces. All of them were completely negative. Okay, that's all for this video. I hope you could understand it. I'll see you in the next video. Don't forget to give me a thumbs up, and goodbye.